Thank you. All right, good. So now we're jumping into eclipse, okay? So when we talk about eclipse, we do see that an eclipse is mentioning when you have a celestial body blocking or casting a shadow onto another. You guys actually got to explore 2 different types of eclipse. Who can give me one? Do you remember what type of one of the eclipse that you guys explored on Monday? Robert, give me one.
Solar eclipse.
Solar eclipse, thank you. And then let me just mark everybody who is hands up. And then Abigail, what was the other one?
The lunar eclipse.
Lunar eclipse. Okay. So again, eclipse is when one celestial body temporarily obscures or casts a shadow on another. So let me clear your hands because I'm not sure if you have questions or not. We're okay? So let's focus on the lunar eclipse first. In order for us to have a lunar eclipse, the moon has to be in the full moon phase. But instead of having a full moon, we have this shadowed moon. Who can help me? Whose shadow is the moon in when it's a lunar eclipse? Which celestial body is causing this shadow? Audie, what's happening here?
The shadow is being caused by the Earth.
Okay, so we have the Earth actually casting its shadow. And this happens when Earth is passing between the sun and the moon. So it goes sun, Earth, and moon. Again, that's the full moon position. And the Earth is casting its shadow on the moon. Now, some of you were asking me on Monday, why doesn't it completely black out? Well, if you think about your shadows, anytime you're casting a shadow on something, it doesn't just completely black out, right? You can still see it, but it's definitely a lot darker shaded this way because of that shadow, okay? All right, if you have your camera off, check in with me. Just put I'm here in the chat box. Thank you, Marcus. Thank you, Faith. Angelica and Izzy, are you still with me? When you're ready, click go faster. I also want to point out that the lunar eclipse takes quite a long time. It takes up to 2 hours for this to happen. Now, I remember one year I was so excited I was going to stay up and watch the lunar eclipse, and man, was it boring. You're just sitting there trying not to fall asleep. Okay, it does take a long time. It's very slow. Okay. When you're ready, click go faster. Okay, thank you, Angelica. Izzy, are you here? Izzy going once? Izzy going twice? Ah, there we go. Make sure you're taking notes as well. All right. So now, somebody mentioned we also have a solar eclipse. Now, this is when the moon is on the opposite side of its cycle. So it's during the new moon phase. This is when the moon is passing between the earth and the sun, right? So instead of a new moon, now the moon, just like our warm up, is going to completely cover the sun. But in order for it to do that, they have to line up perfectly for that to happen. Oh, okay. Just so you know, when you click yes in participants, I just see like how many people are clicking yes. Okay. Armand, you have a question?
I'm not sure if this was a lunar eclipse or a solar eclipse, but I know that one you can't look directly at without like harming your eyes.
So think about it. Which one do you think you shouldn't look at directly?
I think the solar eclipse.
That's right. So in that brief moment that the moon covers the sun, technically it's safe, but it goes pretty quickly. So you do want to use specialized filtered glasses to make sure, or you can use an indirect way. People have like poke a piece of paper and you can see the moon actually in the shadow and stuff move around. So definitely you should never look directly into the sun. The radiation from the sun is so intense that it can permanently damage your eyes. So we don't want to do that. Okay. In fact, for you to actually see a total solar eclipse, you have to be at the right place at the right time. So again, this model isn't to scale, but it's pretty proportionate where the moon is much closer to the earth than it is to the sun. And notice we have what's called this umbra, this dark shadow. And notice that the umbra falls on the earth in just one itty space of the earth. In that space, if you happen to be in this little spot, then you can see the total eclipse. However, if you are in this outer penumbra section that falls on Earth, you can see a partial solar eclipse. And if you're anywhere else on the planet, you won't see it at all. Okay? Hurry up, Rihan. Okay? So you have to be in the right position at the right time for you to see a total solar eclipse. Okay? And it goes by quick. It only lasts for like 12 minutes. And hopefully you saw that in the gizmo. You saw that the solar eclipse went a lot faster than the lunar eclipse. Okay. Let me clear. Click go faster if you're ready. All right, I have 12 of you. So to see a total solar eclipse, it doesn't happen that often, okay? So when it does come up, you do want to try to get those fancy glasses, or you can just punch a hole in like a piece of paper and cast the shadow on the floor, and then you can see the shadow of the moon pass through there. Kind of cool. Okay. All right, again, click go faster when you're ready. I have 12 of you. I'll wait till I have 15. All right. So then normally the next question is, well, when is the next eclipse, right? So for it to be visible where we live in North America, west side, where we can see a total solar eclipse, is not going to be for 3.5 more years. So mark your calendars, set a reminder, April 8th, 2024. But then your next lunar eclipse isn't that far away. It's like 6 months away, May 26, 2021. And again, it'll be visible for much of this side of the planet, the lunar eclipse. Okay. Any questions for me? That's up to you. This is just tidbit information. I normally get asked, when's the next one? Okay. Some people have solar filters on their telescopes. I know Mr. Hines has a solar filter, and I think we had a solar eclipse maybe 2 years ago, maybe 3, and he brought his telescope on campus. So that was really cool. With his filter, you're able to actually see it through the telescope that way. Okay. All right. Yep. Shoebox thing. Again, if you can cast the shadow different ways, there's a bunch of different ways for you to enjoy the solar eclipse safely without you damaging your eyes. Okay. All right, we're going to take a break, stretch, get some fresh air. And when we come back, we have some more things to go over. Here we go. Let's see. I'm debating whether or not to stop sharing. I am going to stop sharing, but before I do that, I need to pin my video. And then there we go. Okay. I'm hoping that will keep us all. No. Here we go. Okay, so I was able to borrow a globe from Mrs. Kim. I do this every year. And when we look at our actual planet, we notice that it is not straight up and down. If it was like this is the North Pole, this is the South Pole, but we notice that it's not, it's like it's tilted. Any wild guesses? Put it in the chat box. Do you know how much it's tilted? What degree of tilt? So you can just put that in the chat box. Wild guesses, good. Okay, good guesses. All right. All right. Thank you for participating. So the planet is actually tilted at 23.5 degrees tilt, okay? And our planet spins. And it spins on this imaginary line of that degree tilt. Let me clear your hands and actually go ahead and put in the chat box. I can give you participation points for this. Who knows what this imaginary line is called for this one here? Good, a lot of you got it. Very good, you guys. So this is called the axis, right? And our planet does two things. Our planet spins and it goes around the sun all the way around at the same time. So I don't know if I'm that talented. So it spins and then goes around at the same time, okay? So now, this spinning, anybody know the fancy word? Go ahead and raise your hand. Oh, don't put it in the chat box. Oh, well. Go ahead and raise your hand. Let's give you some credit for verbalizing this now. The fancy word for that spin. Marcus, what is it?
Is it rotation?
Yeah, so let me record these other folks who raised their hand. Philemon, what were you going to say?
I was going to say the same thing.
Okay, so yeah, it's the rotation. And when we have this going on here, we see that the planet rotates off of its axis this way. Let me get your hands here. Let me lower your hands now. How much time does it take for our planet to rotate once around? What do you think? So our planet rotates on its axis, tilted at 23.5 degrees. How long does it take to rotate once? So, Armand?
I think it takes a day.
Okay. Brianna?
24 hours.
All right. Sahil?
I agree with them, but I also had a question.
Go ahead.
So why is the North Pole where it is? Like why, you know how there's no up and down in space? Why is it called a tilt? Why don't we just imagine that that's straight up and down? Like who says that's a tilt? I don't know if you got my question.
I do. We call this the North Pole, and we see that it's not because the way the planet actually spins pivots right here on these 2 points. When we look at the rate of spin versus the equator to the poles are going to be a lot faster spin, right? Because it's going to be on the edges. So it's going to rotate a lot more. Also, the North Pole always points towards the North Star. So no matter where in our universe, it's kind of weird, the North Pole always points directly at that North Star. Hence the name is this here. Okay, good question, Angelica. That's what we're going to get into is seasons. Okay.
So that's the North Pole, and then why does the one that's straight up and down matter? Like what's that then?
Oh, I see. Because we notice that direct sunlight hits off at a different angle. So we know it's spinning on this axis, but notice that the direct sunlight doesn't equally hit half this way. But the sunlight hits our planet halfway this way, straight up and down. And so that's why we can notice that offset of 23.5 degrees.
That makes sense.
Yes, so Polaris is the North Star, and that's where the North Pole is always pointing at. Okay, so again, it takes 24 hours to completely rotate. It's spinning on its axis, excuse me. And this is the key. This rotation is what gives us night and day, because half of our planet now has sunlight. So it's daytime over here. And then on the opposite side of the planet, it's nighttime. Okay, thank you, Sahil. Yep, take notes. Yes, Arman.
Do we get the effect of the sun rising and setting because the Earth is rotating like in a tilted way?
We get the feeling of the sun rising from the east, setting in the west because it rotates counterclockwise. So since the rotation of our planet is always in the same counterclockwise position, then the sun rises on the east side and then sets on the west side for us. Okay. And again, one complete rotation gives us 1 day. You guys mentioned 24 hours, and I think that's good. Okay. All right, click go faster when you're ready. All right. I'm definitely going to go back in the chat, and for those of you who have been participating, I will mark that down for you guys. Thank you for being active. Okay. All right. Oh, good. I have one person saying go slower. I can wait. When you're ready, though, click go faster.
I should raise my hand.
Go ahead, Sahil.
So the Earth is tilted 23.5 degrees relative to the sun.
Yes. All right. So the next couple slides just recaps what we've actually talked about. So again, we talked about that axis, right? And it's an imaginary line. There's not a real line, but it is where the Earth rotates from. Okay. So again, when it comes to taking notes, you shouldn't be copying it word for word, but just get it in general, especially when you hit high school, especially when you get to college. Your professors don't wait for you. Nobody's asking you to click go faster when you're ready, okay? Well, hopefully they won't when you get to college. Hopefully we're back in person. So, so what I would do if I were a student, I would just put axis, an imaginary line where Earth rotates, done, right? We know it goes from the North Pole to the South Pole. Now that axis is off by 23.5 degrees, and that's what we call the tilt, right? The tilt is slanted, is the slant of the Earth's axis. It's not completely in line with the rays of the sun. It is off by 23.5 degrees here. Okay. Click go faster when you're ready. All right. So we talked about the rotation. Rotation is when it spins on its axis. It takes 24 hours to do it once all the way around. But the sun is not only rotating, it's also going around the sun at the same time. Go ahead and click, raise your hand. Let's not put in the chat box. Raise your hand. What's the fancy word for the Earth going around the sun? What do you think here? Good, I'm getting some new voices in here. Very good. Abigail, what do you think?
Orbiting.
Okay, good. Fateh, what do you think?
Same thing.
Orbiting?
Yeah.
Audie?
Same thing. Orbiting.
Same thing? Okay. Robert, what do you think?
Orbit.
Okay. Philemon?
Orbiting.
Orbiting. Okay. Let me write down these people who are going. All right. Who knows a fancier word than orbiting? Let me clear your hands. Fancier word than orbiting. Angelica, what do you think?
The Earth revolves around the sun.
Okay. Garika, what do you think?
Eclipsing.
Okay. Armand?
Revolution.
Okay. So the fancy word for orbiting is revolution. Revolving, Angelica mentioned. Same thing. So when the Earth goes around the sun, it's going to what we call revolve, revolution. So right now what we're just doing is we finished up our notes about rotation, the axis, and the tilt. And now we're going to our last topic before you do your activity, revolution. Let me lower your hands. How long does it take for the Earth to revolve once? How long does it take for Earth to revolve once? Randy, what do you think?
365 days.
Okay. Matthew?
Isn't it like 365.5 days or something like that?
Okay. Angelica?
1 year.
Okay. Abigail?
Isn't it like 364.5 days?
Okay. Fateh?
12 months.
Okay. Sahil?
365 days and 1/4 of a day.
Okay. And then Abigail, did I get you ready? Yep. Armand? Okay, maybe not. So it takes 365.25 days. Okay. So what does that point to, let me lower your hands. What does that 0.25 day give us? What does that do for us here? Randy, what do you think?
Is it like a leap year?
Okay, what do you mean by leap year?
February 29th.
Okay, thank you. Garika, can you add to leap year?
There's like one extra day in the year or something.
Okay, and so every 4 years we get an extra day. So our revolution around the sun isn't a perfect 365 days. There's a little bit left over. And so what we do is we sort of save those minutes. We just save them so that every 4 years we get an extra day and we add that to February. So February ends up having 29 days instead of 28. Ooh. But again, that revolution is an orbit. You guys mentioned an orbit, you're right. And it's elliptical in shape. Fancy word for oval, elliptical. And this gives us the year. A lot of you put in there 12 months, a year. And so that's what it does for us. Okay. Any questions about this? Click faster when you're ready. I have a couple of you tell me to go slower, so I'll give you a little bit more time. Your gizmo today is having you actually play with direct sunlight, direct and indirect sunlight, and it's going to have you test out different things. So without me giving away your stuff, the formative is quite long, but don't be intimidated by how many numbers there are, because a lot of the numbers are like multiple choice clicks, and a lot of it is data that you're going to just get straight off the gizmo. So it might look a little overwhelming at first, but the questions are pretty straightforward. Okay. Okay. Click faster when you're ready. Do I still have that go slower student? I do. I'm going to give you 30 more seconds and then we're going to move on. Okay. All right. So let's go ahead. We're going to take our final break, stretch, get whatever you need to do. And then when we come back, we're going to get into this gizmo about the seasons. All right, ready? 3 minutes. Let's go.